Bismillah, Alhamdulillah, salatu wassalamu ala Rasulillah. These are some review exercises about chapter 7. If the probability that an event E occurs is 3 over 7, what are the odds that E will occur? Well, let us remember how to find the odds for or in favor of E. The odds in favor of E is given by probability of E over probability of E complement. And we write E complement like this or also like this. Okay, this is another way to write probability of E complement. So probability of E is 3 over 7 and probability of E complement is 1 minus 3 over 7. So 3 over 7 over 4 over 7, that's 3 over 7. So the odds are 3 to 7. This is the odds that E will occur. The odds that E will not occur is the probability of E complement over the probability of E. So it is 7 to 3. Question 4. Suppose that a fair coin is tossed 2 times. We know that when a coin is tossed, one coin, we have H or T. Same coin tossed twice, then the second time I still have these possibilities. So S in this case, the sample space consists of HH, HT, TH, and TT. Okay, HH comes from here, HT comes from here, TH comes from here, the first T and the second H, and TT from here. So there are 4 outcomes in the sample space. Construct an equiprobable sample space. So this is the answer. This is the sample space. And determine each of the following probabilities. What is the probability of 0 hits? 0 hits, that's we have only one outcome, TT. So the probability is 1 over 4 because it is equiprobable sample space. So the probability of each outcome here is 1 over 4. Probability of one hit, we have 2 outcomes in which there is one hit. So the probability is 2 over 4. Probability of 2 hits, there is one outcome with 2 hits. So the probability of that outcome is 1 over 4. Now, if we toss the coin 3 times, then the sample space would be, there will be another here possibility, okay? So I can find the sample space by just writing HH twice. The first time I add H and the second time I add T. The second outcome here is HT, so I write HT twice. Once with H and once with T. And TH, write it twice, add H and add T. And TT is the last choice, TTH, TTT. So there are 8 possibilities, equiprobable sample space. So the probability of each one of these outcomes is 1 over 8. 2 hits. Count how many 2 hits are there. 1, 2, 3. So 3 over 8. 3 hits, there is only one possibility. 1 hit, well, 1 hit means 2 tails. So there are 3 possibilities also. So these are the required probabilities. A deck of 52 cards is shuffled. A card is drawn. So select one card and it is replaced. We put it back. The back is shuffled again and the second card is drawn. So this is selecting two cards with replacements. What is the probability that each card drawn is an ace, king, queen, or a jack? Each card. So uh, let us discuss the first card. What is the probability that the first card is one of these four? So how many of these four do we have? We have four ace, four king, four queens, four jack. Uh, so how many? 16. We have 16. So the probability that the first card is one of these is 16 over 52. And now the second card, so I multiply. What is the probability that the second card is one of these? Again, 16 over 52, because the first card is replaced. So you put it back. So the number of cards will remain 52, and the number of these will remain 16. So that's the answer. A bag contains 4 red balls numbered from 1 to 4, 5 white balls numbered from 5 to 9. A ball is drawn. What is the probability that the ball is red and even? So it has to be red and even. There are 4 red balls. How many of them are even? 2 and 4. So the probability is 2 over the total number of balls. How many balls? 4 red plus 5 white. So the probability is 2 over 9. Red or even? Red or even? How many red balls? 4. Or even? So I take also the even white balls. 6 and 8 are even. So 2 plus 4, there are 6. So the probability is 6 over 9. If you want, you can solve this question like this, or if you want to write more, you can search for, you can write this set, which has red or even numbered, or you can use the formula probability of red plus probability of even minus probability of red intersection even. Okay, so as you wish. Probability of red, how many red balls are there? 4. Even, how many even? 1, 2, 3, 4. 4 are even. Red and even. Well, we have seen red and even two numbers. So the answer would be also 6 over 9. There are different ways to solve this problem. Also this one, white or odd. So I'll just search for white or odd. How many white balls? 5. And I find the odd. I add to them the odd red balls, 1 and 3, 2. So 2 plus 5, there are 7 white or odd numbers. So the probability is 7 over 9. If you want, you can solve it like this, as you wish. A bag contains 4 red balls, 3 black balls. So the total number is 7. 2 balls are drawn at random from the bag without replacements. Find the probability that both balls are red. I can solve this problem in different ways. For example, both balls are red. Think of the first ball. What is the probability that the first ball is red? 4 over how many? 4 plus 3, 7 times. The second ball is red without replacement. So the number of balls now is 6 because I already choose one ball. And I need it to be red. And the first ball was red. So the second ball, so now we have 3 red balls, 3 out of 6 red balls. So this is the probability, 4 over 7 times 3 over 6. If you multiply, you get 2 over 7. You can solve this question in another way. I am selecting 2 balls out of what? Out of 7. So 7C2, and these 7 are divided into 4 red and 3 black, and I need to select two red balls. So 2 from the 3, but 2 from 4, but 0 from 3. Now, if you use the calculator, you have C there. If you multiply 4C2 times 3C0 over 7C2, the answer is also 2 over 7. Or even you can use a tree diagram. Okay, you can say that, okay, the first ball could be red or black. The probability that the first ball is red is 4 over 7. Black 3 over 7. Now the second ball could be also red or black, and you can write the probabilities. Probability that the second ball is red, given that the first is red, 3 over 6, because still 6 balls only and 3 red because 1 red has been selected. And how many black are there? 3 over 6. While here, 3 out of 6. Red, I have 4 red of 6 and 2 out of 6 black, because there were 3 black balls. The first ball was black, so the second being black, I have only 2 black balls and 4 red balls left. So to have both red, so RR, so I multiply 4 over 7 times 3 over 6, and that would be the answer. So you have 3 ways to solve the problem. One is red and one is black. Well, if you want to solve it like this, he did not say that the first one is red or the first one is black. He said one is red and one is black. So I have to consider the two cases. One is red. Let us say that the first one is red. What's the probability that the first one is red? 4 over 7. Times the second is black. How many balls left? 6. How many black? 3. Okay. So this is the probability that the first is red and the second is black, plus there is another probability, or the first is black, so 3 over 7, while the second is red, so 4 over 6. Okay, if you multiply and add, you have 24 over 42, that's 4 over 7. This is one way to solve the problem. Or you can use this one. Okay, what is the case now? You can write C like this or like this. 7C2, that's always the sample space, number of elements in the sample space. And now I have the 4 red balls. I'm selecting one of them, and the 3 black balls, I'm selecting one of them. If you multiply this, you will find also that the answer is 4 over 7. And using the tree diagram, the answer would be red, one black, so RBR. So 4 over 7 times 3 over 6 plus 3 over 7 times 4 over 6 from the tree diagram. So you can also use the tree diagram. A box contains 2 red balls, 3 black. So the total number is 5. 2 balls are drawn from the box without replacement. Find the probability that the first ball is black. What is the probability that the first ball is black? 3 out of 5 times the second is red. Now the number of balls left is 4 because without replacement, and the number of red balls left is 2 because the first was black. So that's the answer. Okay, 6 over 20 or 3 over 10. The second ball is red, given that the first ball is black. All right, here he needs a specific probability. You can use here also the tree diagram or see, but I will use one method only. That's enough. The second ball is red. So the second ball is red, given that the first ball is black. So what is the probability of red given black? You can think of it, okay, also, or you can use the tree diagram here. What is the probability that the second ball is red, given that the first ball is black. So we have selected one black ball. So the number of balls left is 4, and the red balls are still 2 because the first ball selected is black. So the probability is just 2 over 4. Okay. Or if you use the tree diagram, uh, the ball could be red or black. The first ball, I have 2 red balls, 3 black balls. Now I need the probability that the second is red, this one, given that the first is black. So this probability is the one I need. Now I still have 4 balls, 2 red. So the probability, this probability is the probability of R given B. Remember, in the tree diagram, these probabilities are given probabilities. These probabilities here are given probabilities, conditional probabilities. So this is the conditional probability. And he is asking here about conditional probability. A bag contains 8 white balls, 5 red, 7 black. So the total is 20. 3 balls are drawn from bag with replacements. With replacement, this means that the ball will be replaced. You put it back. So here without replacements, here with replacements. With replacement means you can take the same ball twice or 3 times. So here you cannot use C. The method of C is not used here, okay? Because to use C, the balls has to be different. So the experiment has to be without replacement. With replacement, you do not use C. So either you use the tree diagram or the method that we use quickly. The first 2 balls are red. So the probability that the first ball is red, how many balls are red balls? 5 out of 20. This is the first ball. The second ball also 5 of 20 because the experiment with replacement. You put it back. So the number of balls is 220 does not change. The third ball is black. How many black? 7. So that's the probability. 2 of the balls are red and 1 is black. And he did not mention which 2 balls are red. So 2 are red. So 5 over 20 times 5 over 20 times 1 is black, 7 over 20. But this is only one possibility. There is another possibility that the first is red and the third is red and the second is black. And there is a third possibility in which the first is black and the second, the third are red. But all of these 3 possibilities have the same probability. 5 over 20 times 5 over 20 times 7 over 20, but the position will be changed. So instead of writing plus 3 times, I can multiply by 3, and this will give you this probability, the answer to the question. A bag contains 8 white balls, 5 red, 7 black, without replacement. Okay, without replacement, I can use C here. Okay. The first 2 balls are red and the third is black. If I use the same method, the first ball is red, so 5 over 20. The second is red. Now I have 19 and 4 red balls. The third is black, so I have 18 left, and the 7 black are still there because the first and the second were red. So this is the probability in this case. The third ball is black, given that the first is black. So I have the information that the first ball is black. The probability, if the first ball is black, what about the second ball? He did not talk about the second ball. So the second ball could be any of these three. So let us use the tree diagram to make it easier. The first ball could be red, black, or what? Or white. Now, if the first ball is black, so I'll concentrate here. The second ball could be red, black, or white. And then the third ball could be red, black, and white, red, black, and white, red, black, and white. So when he says that uh, the third ball is black, given that the first is black, he has, yeah, the first two. He meant here, he has to mean here that the first two are black, because then he is asking about this conditional probability. Because otherwise, he's discussing this B, R, B, and B, 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 and BW, B. Okay, but then it is not a conditional probability. So it has to be one probability here he is asking. So I'll answer this question as the first is black. So if the first is black, we have selected one black, and the second one also two blacks. We have selected two black balls. So the probability that the third is black, given that first two are black, is, I still have 18 balls because this is without replacement, and I have now 5 black balls. So the answer is 5 over 18. How many combinations of 8 things taken 5 at a time are possible? Combinations that see we have 8 things taken 5 at a time, so it's 8C5. If I use the calculator, the answer is 56. In a certain city, 30,000 citizens out of 80,000 are over 80 years, 50 years of age. What is the probability that a citizen selected at random will be 50 or younger? Okay, so 30 are over 50. What about 50 or younger? The remaining are 80,000 minus 30,000. That's 50,000. So what is the probability that the citizen selected is 50 old or younger? The probability is 50,000 over 80,000. Or you can say 1 minus 30,000, because this is actually the complement of 50 over 50 years of age. According to funny2.com, the odds that a person aged 18 to 29 reads a newspaper regularly are 1 to 3. So this is the odds that the person reads a newspaper regularly. What is the probability that such a person selected at random reads a newspaper? So if we call reads a newspaper is E, so, and this is the odds in favor of reads, in favor of E, okay? So there is a formula. If the odds in favor are A to B, in favor of E, odds in favor of E are A to B, okay? This is a formula and we studied in the first section. Then probability of E is given by A over A plus B. That's the formula. So probability of reads the newspaper, in which we called A, is 1 over 1 plus 3. So it's just 1 over 4. Of 100 job applicants to the United Nations, 30 speak French, 40 speak German, 12 speak both French and German, both. So that's the intersection. If an applicant is chosen at random, what is the probability that the applicant speaks French or German? So he's asking about probability of F or G. And this would be probability of F plus probability of G minus probability of F intersection G. And probability of F is 30 over the total, which is 100, plus 40 over 100 minus the intersection, which is 12 over 100. So if you add, it is 58 over 100, and that's the answer. We have this table, and the question is, find the probability that a person chosen at random has a democratic style. What is the democratic style? This one. And so that's the intersection and medium. So he is asking about this number. So the probability of democratic intersection medium is 25 over the total number, which is 280. So that's the probability of democratic intersection medium. Find the probability that an individual chosen at random has high productivity, high, so he's asking about high now, or an authorization, uh, authoritarian, authoritarian style. So this is the authoritarian style. He's asking or, okay, or. So high or authoritarian. How to find or from here? You can use the formula, probability of high 75 over 280 plus 120 authoritarian over 280 minus 30 the intersection. You can do that. Or to find the union, these are all the high, okay, and you add to them all the authoritarian that are not high. So in fact, 75, that's the total, 75 plus 15 plus 75, or 120, okay, plus 25 plus 20, as you wish. So I'll do it like this: 75 plus 75 plus 15 over 280. So it's 165 over 280. Can solve this question in different ways. Okay, I told you already two of them. Find the probability that an individual chosen at random has an authoritarian style given that, so he's asking about probability of A, authoritarian, given that he or she has medium. To find the probability of given, medium now is our sample space. So 110, okay? The total number of medium is 110. Remember, the definition of given is probability of A intersection M over probability of M, okay? Or number of medium over number of elements in the intersection. In the intersection between A and M, I have 75. So the answer is 75 over 110. A product must pass an initial inspection where the probability that it will be rejected is 0.2. Let me do a tree diagram. There are two possibilities, rejected or not rejected. Probability of rejecting is 0.2, so probability of not rejecting would be 0.8. If it passes the inspection, no, not rejected, it also must pass a second inspection. It could be rejected again or non-rejected, where the probability that it will be rejected again here is 0.1. Not rejected then would be 0.9. What is the question? What's the probability that it will pass both inspections. So N and N. So the probability is 0.8 times 0.9 to find the probability of the intersection. Okay, you multiply 0.8 times 0.9 and the answer is 0.72. Find the probability that a car is an automatic. Select one car. We will select one car. What's the probability that it's automatic? How many automatics? All of these are automatics. So we add all of these probabilities. 0.32 plus 0.27 plus 0.21. If you add, I think you get zero point 0.8. So the probability is 0.8. Part B, find the probability that a car is an automatic given that SUV. I can write it like this, SUV, okay? So SUV will give you the sample space. So 0.21 plus 0.07. And I need A automatic and SUV. So this one, 0.21. So I divide 0.21 by 0.21 plus 0.07, use the calculator, and the answer would be 0.75. Automatic and SUV are automatic and SUV independent. Well, how to find out whether the two events are independent or not? This is automatic and this is SUV. I can use this answer here of part B. Probability of A automatic given SUV equals 0.75. And this does not equal to probability of A because we find that probability of A in the first part is 0.8. And to be independent, A and SUV to be independent, probability of A given SUV has to be equal to probability of A. That's one of the definitions of independence. So the answer is no, not independent. Okay. You can solve it in another way if you like. You can prove that probability of A intersection SUV is not equal to probability of A times probability of SUV. This is also another way to prove that it's not independent. Okay. This is another way. Or both will be correct. Find the probability that a car is convertible given that it's a manual. So convertible, let me call it C. Manual, let me call it M. So manual is my sample space, so I will divide by all the manuals. 0.08, 0.05, 0.07. And I need convertible. Convertible 0.08. That's the intersection. That's the probability of the intersection between convertible and manual. If you use the calculator and divide, the answer is 0.4. The answer is 0.4. Okay. Are convertible and manual independent? Okay. This is the probability of convertible given manual. Is it, let me 0.08 over, yeah. Is probability of convertible given manual, is it equal to probability of convertible? If it's equal to probability of convertible, then they will be independent. This is 0.4. Okay. What about probability of convertible. This is convertible, 0.32 plus 0.08. And that's 0.4. So the answer is yes, they are independent. And if you want here also, you can find the probability of C intersection M, and you will find that it's equal to probability of C times probability of M. These are always two ways to prove independence. A personal director ranks 4 applicants for a job. How many rankings are possible? We need to rank 4 people. So 4P4 or 4 factorial. This is one way. If you want to solve it using the product uh, uh, principle, or we call it MN principle, think of the first applicant and how many ways you can rank him. 4 ways. The second applicant now 3 ways. The third to the last one. So it's 24. An organization wants to select a president, vice president, secretary, and treasurer. 4 people. Each one of them is different. So there is an order here. There is an arrangement. 8 people are willing to serve. In how many different ways can the offices be filled? So I need to select 4 out of 8. So the answer is 8P4, and you can use the calculator and you will find that this is the answer. Or you can think of it like this. Choose the president first. How many choices are there? We have 8 people. Choose the vice president. Now we have 7 people, then 6, then 5, and it will give you the same answer using the MN rule or the product rule principle. A utility company sends teams of 4 people, each to perform repairs. So these 4 people will perform repairs. There is no difference between them. They construct one team, okay? So if it has 12 qualified people, how many different ways can people be assigned to a team? So we have 12 and we need to select 4 of them without order. So this is just 12C4. If you use the calculator, the number is 495. Organization wants to select a committee of 4. Also committee, no chain, no difference between the 4 members from a group of 8. How many different committees? 8C4 combination, and the answer is 70. A college registrar adds 4 new courses to the list of offerings for the spring semester. If he added the course names in random order, so there is an order here, okay, of adding the names at the end of the list. Someone could be the first, the second, there is an order. What is the probability that these 4 courses are listed in alphabetical order? Listed in alphabetical order, this is one possibility. And how many possibilities are there to arrange 4 courses in order? That's 4P4 or 4 factorial. So the probability is 1 over 24. A supplier has 200 compact discs, of which 10% are known to be defective. 10% out of 200, if you multiply 10% times 200, then 20 are defective. If a music store purchased 10 of these discs, what is the probability that none is defective? Well, I have 200. I will write it like this. And I want to select how many? 10 of them. What's the probability that none of these 10 is defective? These 200 are divided into 2 groups. 180 non-defective good, and 20 are defective. I need what? Non-defective. So 0 from the 20, 10 from the 180. And you can use your calculator and find the answer, and the answer would be 0.34 after approximating. Uh, correct to 2 decimal places. 2 of the disks are defective. Okay, so I am selecting 10, but this time I need 2 of them defective, so 8 will not be defective, and multiply, and the answer would be approximated to 1 uh, decimal is 0.2. A sample of 6 fuses is drawn from a lot containing 10 good and 2 defective. So in total 12. So we are selecting 12 from 6. Find the probability that the number of defective fuses is exactly 1. So I have 12, and these 12 are divided into 10 good and 2 defectives. And I need to select six of these 12. And I need 1 to be defective. So 1 from the 2, and the remaining 5 are from the good. So use the calculator. 10C5 times 2C1, this will be 6/11. At least one defective, okay? At least one means always 1 minus probability of 0 defectives, okay? 0 defectives. So it's 1 minus. You can find it in another way, okay? Because we have only 2 defectives. So you can find probability of 1 defective plus probability of 2 defectives, or 1 minus probability of 0 defectives. I'm choosing 6 out of 12. 0 defectives mean I'm choosing all the 6 from here, and here I'm choosing 0. Okay. If you find the answer using the calculator, the answer is 17/22. This was the last question. I hope you enjoyed this review about chapter 7.